Hey, what's up, Morpheus? Welcome back to the commute, and in this video we are going to learn about concurrency versus parallelism. We are also going to talk about synchronous and asynchronous, so there'll be a lot to learn around coroutines and threads. So I've seen that a lot of Android interview questionnaires and interviewers love to talk about coroutines and threads, so this will be a good introduction to that, and hopefully you guys really enjoy it. And if you did, you know what to do: like and subscribe, and as always, let's get started. Now let me quickly explain to you the difference between concurrency and parallelism with this particular whiteboard, and this will give you a very good idea. This is the concurrency versus parallelism, and also we will be talking about asynchronous and synchronous. We'll talk about everything right here. Now let's first of all talk about concurrency. As you can see, this is the definition of concurrency right here. Concurrency involves overlapping task execution on a single processing unit. It allows apps to handle tasks like network requests, database operations, and UI updates without freezing the main thread. Now what does this particular thing mean, overlapping task execution? Let's look at this with an example, and it will give you a good overview of what is happening in concurrency. Okay, let's try to draw it first of all. Please excuse me for my drawing. I'm not that great at drawing these things, and I'm drawing with my mouse here. So let's just say this is a CPU, and this is a single core CPU. It means that it only has, let's just say, one thread. Okay, this is task 1, this is task 2. Okay, this is T1 and this is T2. Hopefully you can see these two things, and what we need to do is basically execute these two tasks simultaneously. Only the problem is that we have only single core. It means a single core can work only on one task, but we need to actually execute these two tasks simultaneously. How can we do that? The idea is that we switch between these two tasks and try to finish them simultaneously. Okay, this is called context switching. You must have heard about context switching. You can read different blogs about context switching and how it is done. It appears as if both the tasks are being executed simultaneously, but they are not. Okay, the CPU goes into task 1. It starts working and gets stopped right here. Maybe the task 1 is stopped because it requires it has done some kind of network call, and it is waiting for the network call to return and provide the data it needs. Right now, as of now, the task 1 is waiting. Right now, what this particular thread can do is actually switch to task number 2. Right, and it starts executing the task number 2. Right, again task number 2 gets stopped right here because it has also done some kind of maybe a database request, and it is waiting for the data to come. Right, by the time the task number 2 was executing, the data has already arrived from task number 1, and what this particular thread does is basically switches again to task number 1, and it gets stopped somewhere right here again, and then again the task number 2 gets start executing. The thread switches from task number 1 to task number 2, and this goes on and on until both these tasks gets finished right here. Okay, both these tasks gets finished, and it appears as if these two tasks are being executed simultaneously, but instead the thread is actually switching the context between these two. That is what concurrency actually means. The concurrency is the idea that the task will always be in progress. So the key thing that we have to keep in mind is that both of these tasks are always in progress, and that's the idea of concurrency. That's why we say that concurrency is a type of parallelism, but parallelism is not concurrency, and that's what exactly in progress means for concurrency. Okay, concurrency involves overlapping task execution. That is what overlapping task execution means, that we are trying to execute two different tasks simultaneously and with the help of context switching. Let's talk about parallelism, and it will actually make it more clear to you. Now let's try to look at parallelism and how is it different from concurrency. Now parallelism uses multiple CPU cores to execute tasks simultaneously. In Android, this is critical for compute heavy tasks like image processing or batch data operations. Now what is happening right here is that let's try to draw one CPU so that we can imagine the parallelism right here. Again, let's try to divide the CPU into 4 parts, and let's just say that this is 1 core, 2 core. Now this is task 1, again T1, excuse my line here, and this is T2. So these are two different tasks right here. Now what is happening is that it is using multiple CPU cores. It means, let's just say that this 2 is dedicated to actually execute T1, and this 4 is dedicated to solve T2 task. And what is happening is that parallelism uses multiple CPU cores. Now what is happening is that both of these tasks are being executed simultaneously right here. They are not switching context to, these cores are not actually doing context switching right here. They're trying to execute it completely right here. with their individual cores, and that is what parallelism means. They are not doing any kind of context switching. They are focusing on their own individual task and trying to complete it simultaneously. That is what parallelism means. The key word here is execute task simultaneously. In concurrency, tasks are always in progress simultaneously, whereas in parallelism, tasks are being executed simultaneously. Hopefully, it makes it much more clear to you guys. And what is the key difference between concurrency and parallelism? Let me quickly give you an overview of what is synchronous and asynchronous, and that will give you a good idea of how it relates to parallelism and concurrency overall. Now, let's try to look at the definition of synchronous, okay, and how is it different from asynchronous. Already must have seen examples of this in your day-to-day code in Android. Okay, let's try to look at the definition. It means tasks are executed one after another, where each task waits blocks for the previous one to complete before starting. It is a blocking model where operations happen in a strict sequence. Let's try to look at this with an example. Okay, what is happening here is this is a CPU core, right? It might be multiple, it might not be multiple core CPU. It doesn't matter. Now what is happening is this is a task, right? T1. Now this particular core is working on this. All the rest of the 3 cores are not allowed to work on any other task until and unless the T1 gets finished. When T1 gets completely finished, only then the core can actually start working on T2 task, right? Until unless it is finished again. So what is happening here? It means that tasks are executed one after another, where each task waits and blocks for the previous one to complete before starting. So this task completely blocks this core to switch or to do any other thing. And this is what synchronous means, that one task is being executed and only one task shall be executed until unless it's completely finished. Only then the task 2 will be starting. And this is what we call a blocking. What will happen? Let's just say that this takes 1 second to execute. This takes 1 second to execute. So both of these will take 2 seconds to execute. Now let's try to look at asynchronous. Okay, now what is asynchronous right here? Asynchronous, it is a non-blocking model where a task can start and then yield control to other tasks before it finishes, allowing multiple tasks to be in progress without waiting for each other. And that is what concurrency actually means, right? A CPU core is particularly working on one particular task. Let's just say T1, right? And it is waiting for some kind of result to come along. Now this thread actually switches to particular T2 task until unless we are getting result from T1, and tries to execute the T2, and it will stop and wait for its own result. And T2, the thread will again switch from T2 to T1 and try to execute T1 and T2 simultaneously, almost simultaneously, in almost concurrent manner. And that is what asynchronous actually means. These are the differences between how asynchronous, synchronous, concurrency, parallelism, all of these definitions, and hopefully it makes it very clear to you guys and gives you a very good overview. If you want to read more, you can read very good articles online, and that will give you a very good overview and actually revise your concepts. Hopefully you guys really enjoyed this section, and if you did, you know what to do. Like, share, and subscribe, and I'll catch you next time. Bye bye.